Okay, hi guys. So in this lecture, we'll be seeing or practicing some more examples on Pinacolone rearrangement. So we have seen some of the examples in the previous lecture. So here also we'll be seeing, and we'll be continuing on seeing some more examples. Okay. So we have something like this. Other. It should be directly OH, and this is this group. Okay. So H plus and heat. What would be the product? Product would be something like this. Okay. Mechanism is simple. On this carbon atom or on this carbon atom, this is having 1 2 3 alpha hydrogen only, and this will be having 6 alpha hydrogen. Okay, so this is having 4 alpha hydrogen, this is having 6 alpha hydrogen, so carbocation would be formed here first. So we would have something like this, and then we would have this, then obviously this is OH, so again CH2 minus shift would be there, which would be something like this. We have a positive charge here, OH attached here, and this group as it is. Then again something like this, and H bond will be taken back. We would have something like this as our product. Okay, let's look at another example. We have this and this, and in presence of AgNO3. So we know that in presence of AgNO3, iodine will go along with Ag and create a precipitate. If you are not sure about the precipitation reaction and how this goes, nothing to be bothered about it. Just have to remember that carbocation would be formed at the leaving groups or I minus position. Okay, so we'll talk about more about precipitation reaction, the color of the precipitate, salt analysis, and various other aspects in our inorganic chemistry lectures. So go ahead and watch those lectures. Those are also very good. Okay, so now we will have CH3 minus shift. So we'd have positive charge here, OH attached here, and again we have a formation of Pinacolone. Okay, let's look at third example. Here we have a cyclopentane ring, OH attached here, and CH2Cl here. What happens if we react it with AgNO3? Again AgCl will kick out and forming a positive charge at this carbon position. We will have something like CH2 plus. Now what will happen? Ring expansion. Okay, this bond will be creating positive charge here, and would be this bond will break up, and this carbon atom will directly join with this carbon atom. So cyclohexane ring would be formed with this carbon positioned here. This carbon is 2, so 2 is here. This carbon is 1, so 1 is here, and then on OH we have a positive charge. Again we will have a formation of this. Okay, so let us see an example of epoxide. When we involve epoxide, 3-member epoxide is highly unstable in all medium, acidic or basic. We actually saw this example in previous lectures also. So what will happen is, again what we have is something like O plus H here. Again, this would be the RDS in which carbocation formation would be there. Okay, now what will happen is again CH3 minus shift. Why? Because of the formation of, we cannot leave our IIT cation behind, which is highly stable. This is our IIT cation. Okay, again what will happen is, again this will form a double bond with neighboring carbon atom and with the release of H plus, so this will be our product formed. Okay, so this reaction actually happened in the same fashion as Pinacolone rearrangement, so we can say that it is a Pinacole fashion rearrangement. Okay, now let's continue with some more examples. So this example is very important. So it has been asked quite some time in national level Olympiads, and in JEE level examinations as well. Okay, so we have something like this. So what will happen is, we would have, the product would be something like this. This is a 7-member ring. Now the main question is, how is the ring formation takes place? We know that from 6th to 7th it is not a feasible step. So then how the mechanism goes for this reaction? So as you know, the I minus will break out from the C bond and will create a precipitate with AgI. So we'll be leaving with a positive charge here. Now we also know that the IIT cation is highly stable cation, and it is very much favored in any intermediate process of a reaction to go that in the forward reaction. So anyhow we want plus charge to be at this carbon position, but if you see at this carbon, I actually do this wrong. Yeah, but if you see, this CH2 group is at the same position at the same carbon on which OH group is also attached. So anyhow we want a positive charge on this carbocation, because if a positive charge is on this carbon, then IIT cation or the resonating structure can be there, which is highly stable. Hence, and so first step is, we need to see whether H minus shift or CH3 minus shift is possible in this case or not. No, it is not possible. Why? Because the two bonds of the carbon are going into the ring for the ring formation, and one other is going to OH, so no other H or CH3 is left. But we are actually left with what is called a ring expansion, because if we go into having a ring expansion, this carbon bond will actually break this bond between the first carbon atom and itself. Hence it will get a positive charge here, and it would form a ring, and it will include this carbon or the third carbon also inside the 7-member ring, which will be hence formed, right? But so our main idea of having a positive charge on first carbon is satisfied, and the establishment of highly stable carbocation or intermediate can be formed. Okay, so this actually goes in the forward direction with the formation of a 7-member ring. 1 2 3 4 5 6 and 7. So if we number these carbon atoms, so we'll get something like 2 3 and first we will have a positive charge and CH3 attached here. OH attached here. Okay, and now it will convert into this group. So if you look at the bond energies, I actually told you in the previous lecture when we were starting Pinacolone rearrangement chapter or topic. So I actually told that the bond energy of CO bond, the double bond, is 375 kilojoule per mole. So if the bond energy of this was X, then this would be X minus 375 plus 50. Why plus 50? I'm just assuming that approximately 50 kilojoule per mole is required for the formation of breaking of 6-member ring and converting it into 7-member ring. But still the bond energy is much higher than it was in the previous case, hence the reaction will go into the forward direction. Okay, so it was a very good example, and this type of questions are asked several times. Okay, so let's look at the last important concept here. So suppose we have I will explain the concept with the help of an example. Suppose I have something like this and this, and we are reacting it with TCl in the presence of ETN3. Okay, so what would be the product formed? So the first step, let's go into the first step. In this case, this compound would act as a nucleophile for this compound, and when we're talking about nucleophile, we'll see that this oxygen atom, or the first oxygen atom, would be more or a better nucleophile than the second one. Why? Because when you look at the second oxygen atom, it is surrounded by 3 bulky groups, CH3 on the same carbon, right? But if you look at this oxygen atom, it is just surrounded by 2 smaller H atoms. So this would be a better nucleophile, and hence this lone pair would be better accessible to the TS group. Okay, so what will happen is this O will attack on TS and Cl minus will be removed as a result. So we will get something like this. Now we know that OTS is a very good leaving group. Okay, so what will happen is this will move out, taking its electron from taking the carbon's electrons also with itself, or the bond electrons, that would actually establish a positive charge here. And after the establishment of positive charge, what will happen? We need to again rearrange the positive charge on this carbon atom. Why? Because of the formation of highly stable IIT cation as an intermediate. Why? Because this can actually involve itself with resonance with the positively charged carbon atom. Hence, CH3 minus shift will take place. So I am talking all these steps so that by now you should be able to think all this in your head, and I need not write it again and again. We have been practicing it for so long, and so many examples we have done so far. Okay, so what will happen is, again after the CH3 minus shift, this carbon atom will get a CH3 from here. Okay, this is CH3 minus shift. Okay, as a result, this carbon atom would be getting positively charged. Okay, and as a result, the lone pair of oxygen atoms will be forming a double bond with this carbon atom, and this hydrogen would be removed from this oxygen atom. So what would be the final product? It would be something like this. Okay, so I hope you are able to follow this step. Okay, so with this we come to an end of this lecture. I hope you had a good session. So till then, good luck and goodbye.